What happens when you drop a 5 kilogram ball and a 10 kilogram ball from the same height above the ground? Which one hits the ground first? You might think that the 10 kilogram ball would hit ground first, but they both end up hitting the ground at the same time, assuming there is no air resistance. The reason why this is because all objects close to Earth with no air resistance accelerate at 9.8 meters a second squared towards the center of the Earth. I want everyone to remember that the acceleration in the y-axis is always 9.8 meters a second squared towards the center of the Earth. But what does the y-axis mean? The term y-axis basically just means everything up and down, while the term x-axis is everything left and right. It's like a grid. These two axes don't interfere with each other, so if there's a velocity in the x-axis, that does not affect the velocity, acceleration, or displacement in the y-axis. Let's get back into projectile motion. So what's the acceleration in the x-axis? Well, imagine a world without air resistance. If you're driving in your car and you throw a ball directly up out the sunroof, the ball should go up and then come right back down into the car. This is because the velocity in the x-axis does not change at all throughout the trip, so there's no acceleration in the x-axis. Let's look at this with an example of a ball pushed off a cliff. If the ball has an initial velocity of 5 meters a second in the x-axis and 0 velocity in the y-axis, and after 1 second the ball still has a velocity of 5 meters a second in the x-axis and 9.8 meters a second down in the y-axis. This trend continues, so at the bottom the velocity in the x-axis is still 5 meters a second, and the velocity in the y-axis is 9.8 meters a second squared multiplied by the time it takes for the ball to hit the water. I have a table here to show the velocity more precisely. The final important part of projectile motion is initial velocity of the projectile. Your teacher might give you a question like this. A golfer hits a ball at a velocity of 20 meters a second at an angle 30 degrees with the horizon. How far does the ball go? This velocity has a component in both the x and y axis, which means we have to use SOHCAHTOA rules from trigonometry to find the values. For initial velocity in x, we can use cos 30 times 20 meters a second, which equals 17.3205 meters a second. And for initial velocity in y, we can use sine 30 times 20 meters a second equals 10 meters a second. So how do we know how far the ball goes? Well, we know that the ball will only stop moving after it hits the ground. So we have to find the flight time of the ball. Let's use this kinematic equation. Displacement in y equals time multiplied by initial velocity in y plus 1/2 acceleration in y multiplied by time squared. We know displacement in y equals 0 because it landed at the same level as it started with. We can fill in initial velocity as 10 meters a second up and acceleration in y as 9.8 meters a second squared down, which means it becomes negative 9.8 meters a second squared down. If I simplify this equation and factor out one of the times, then we can find the flight time to be 2.041 seconds, which means to find how far the ball will go, you have to use the same equation from before, but now in the x-axis. Obviously take out the acceleration part because there is no acceleration in the x-axis like we already talked about. This will result in an x displacement of 35.35 meters north, which is how far the ball will go. Please comment any questions you have or the type of content you'd like to see in the future. Please like and subscribe.